Session 4.4 Counting. Remember the basic probability formula. We have probability of A equal to favorable A over the total outcome. Okay, so from session 4.1 to 4.3, we talk about the probability. But these sessions, we talk about the counting. Counting means we want to find out what is the total outcome. Okay, so for these sessions, read the question carefully. Are we looking for the probability or are we looking for the total outcome? Definition: fundamental principle of counting. If an operation can be performed in m ways and a second operation can be performed in n ways, then the total number of ways to perform the sequence of two operations is m times n. So if we could have m ways and n ways, we only have two different ways, and we want to find out the total number of ways to perform. So you just need to multiply it together. For example, a certain make of automobile is available in any of three colors, red, blue, and green, and it comes with either a large or small engine. How many ways can a buyer choose a car? So we are looking for how many ways. We want to find out how many total outcome instead of looking for the probability. So first, we have three colors. Okay, three colors, and then we have two sides, the large engine or small engine. According to the fundamental principle of counting, we just need to multiply it. So 3 times 2, that will be equal to 6. Okay, so we have three color, and each color we have either large or small engine. So you could see we have 1, 2, 3, 4, 5, 6. Okay, we have 6 different ways for the buyer choose a car. Okay, how about what is probability to get one vehicle with a small engine or one green car with large engine? So this time we are looking for the probability. So we need to one red car with the small engine. Okay, so it'll be this guy. Or a green car with large engine. So we have these two. So we'll be using the basic probability formula. We have two of them. Out of how many outcomes do we have? We have 1, 2, 3, 4, 5, 6. So that will be 2 over 6. Okay, and that will be 0.33. Okay, next example. License plate in a certain state contain 3 letters, followed by 3 digits. How many different license plates can be made? The letters and the numbers can be repeated. So since we have 3 letters, okay, we have a 3 space for the letters and followed by 3 digits. Okay, and first one, we're gonna put in the letters here. So think about it. How many letters do we have? Okay, we can choose from A, B, C, D, E, F until X, Y, Z. So we do have 26 letters in here. Okay, second one, that will be the letters again. We will have the same thing from A, B, C to X, Y, Z here. We still have 26 letters. Same idea with the third one. Okay, after that, we're gonna follow it by 3 digits. So how many digits you can choose? We have a choice from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So from 0 to 9, how many digits do we have? We have 10 of them. Okay, so second one is gonna be the numbers again. We still have 10 choice. We still have 10 choice in here. So according to the fundamental principle of counting, we just need to multiply all together. Okay, I want you guys try to do the part B. Similar questions, but this time letters and the numbers cannot be repeated. Means if you use the A for the first one, you can't use the A for the second one anymore. Okay, check your work. Again, we have a 6 space here. First one, we do have 26 letters to choose. And then second one, let's say for first one, we picked the A already. So for the second one, we can't pick the A anymore. So right now, we only have 25 letters left. Okay, this one, we have the same choice. And let's say we take the A for the first one, B for the second one. So we can't take these two anymore. So right now, we only have a 24 letters. Okay, then how many digits do we have? We have a 10 digits. And again, let's say the first one we pick the 0, we can't pick the 0 anymore. So we only have a 9 left. The last one, we can't pick the 0. For example, we used the 1 already, so we only have 8 numbers left. Okay, multiply all together. You should find this answer. Okay. Factorial rule. For any positive integer n, the number n factorial, okay, this is called n factorial, is equal to the product of all the integers from n down to 1. Means n factorial be equal to n times n minus 1 times n minus 2 until you got like 3, 2, 1 here. Okay, this is the meaning of n factorial. Okay, for example, 5 factorial. What is a 5 factorial? That is means like 5 times 4 times 3 times 2 times 1. Okay, we're gonna stop it here. So use a calculator. That will be equal to 120. Okay. Okay, for the factorial, you guys can use the calculator to take care for it. So use your calculator. You will have a 5. And then go to the math. And then you're gonna see this is a PRB, this is a probability. So you could use the arrow button, go to the right. And then for the number 4, that will be factorial. Okay, 5 factorial. Enter. You're gonna see 120. Okay, next one. I want you guys try to use the calculator to find the 0 factorial. Okay, do the same thing. Click on 0, math, probability, factorial. Okay, what do you guys get? That will be equal to 1, okay? 0 factorial, that's a special number. That will be always equal to 1 in here. Okay, you could follow the notes, how to use your calculator to find the factorial. Okay, number 3. How many ways can the letters of A, B, C be arranged? Okay, so you could look at here, I have a 3 letters. And then I don't have a repeated letters. And I want to know how many ways I could rearrange for these 3 letters. So think about it. I have a free space in here. For the first one, how many choice do we have? We could choose from A or B or C. So we do have a free choice from here. And then let's say the first one, we picked the A already. So right now, we only have 2 choice. Okay? And then the last one, let's say we pick the B for the second one. So right now, we only have a 1 choice in here. Okay, by the fundamental principle of counting, we could just multiply all together, right? But think about it, what is a 3 times 2 times 1 equivalent to? This is equal to 6, right? But we just learned that that's called 3 factorial. Okay, 3 factorial. So use a calculator, or you could just do quick math in here. 3 times 2, that would be equal to 6. Means you do have 6 different ways to rearrange this letter A, B, C. Okay, that will be these 6 guys in here. Okay, on the homework or exam, you don't have to write it out. I just show it to you guys. You could see we do have a 1, 2, 3, 4, 5, 6. 6 different ways to rearrange these 3 letters. So every time when you guys want to arrange the letters, when we don't have the repeated letters, you could just count how many letters do you have. I have 1, 2, 3, so there are just 3 factorial. Okay, try this example. How many ways can the letters of this guy, these letters, be arranged? Again, no repeated letters. Okay, so we have how many letters here? 1, 2, 3, 4, 5, 6. So that'll be 6 factorial. Use the calculator. You should get 720 ways. Okay, we have a 720 ways to rearrange this letter. Okay, permutation rules. When n different items are available and all of them are selected without replacement, the number of different permutation is given by NPR. Okay, we call this as a permutation. You could see NPR. And N, this is talking about how many items you have it. Okay, how many items do you have? And R, that'll be how many you want to pick it from the N. And when we use the permutation rule, this means the order doesn't matter. Okay, the order doesn't matter. Look at this example. We have an ABC and then we want to choose 2 of them. And order doesn't matter. Okay, order doesn't matter. So first, think about it. What is your N equal to? What is your R equal to? N represent how many items are available. So we have 1, 2, 3. We have 3 items. And how many you want to pick? That's called R. So we want to pick 2 of them. So R equal to 2. Okay, and they say order doesn't matter. Order doesn't matter means AB does not equal to BA. We could count this as 2 different ways. Okay, since order doesn't matter, so we're gonna use the permutation. Okay, permutation rule. That would be 3P2 here. You could plug in to the formula, do the math. So this is gonna be 3 factorial divided by 1 factorial, which is gonna be equal to 6. Okay, so we have these 6 different ways to arrange these ABC when you pick 2 of them. Okay, one more time. Order doesn't matter means AB does not equal to BA, or AC does not equal to the CA here. Okay, or you could just use your calculator. We're gonna do 3P2. So we're gonna click on the 3, go to the math, go to the probability. You're gonna see the number 2, that's an NPR. Okay, we just learned the factorial. Right now, that'll be NPR. The next part, we're gonna talk about the NCR. Okay, so right now, we're gonna choose number 2, and R will be equal to 2. Okay, one more time. N equal to 3, R equal to 2. Enter. That will be equal to 6. Okay, try to do this example. Okay, 5 lifeguards are available for the duty one Saturday afternoon. There are 3 lifeguard stations. In how many ways can 3 lifeguards be chosen and ordered among the station? Okay, so we're gonna figure out what is your n here? We have a 5 lifeguards here, so n equal to 5. How many do we want to pick? We want to pick 3 of them, so R will be equal to 3. And this is specific that the order among the stations means the order doesn't matter. So that's why we want to use the permutation. That would be 5p3. Okay, or just use your calculator, you could get 60. Okay, try this one. Okay, this one, we have n equal to 46, and they want to visit like in 4, okay? 4 capitals. So that will be 46p4. Okay, just use your calculator. You could get like this big number. Okay? Okay, B. What is probability that she selects the roots of 4 specific capitals? Okay, we are looking for the probability. So we'll be using the favorable outcome over the total outcome. So we only have a one root of the 4 specific capitals. So that will be 1 over the total outcome. Okay, the total outcome is going to be here. Okay, permutation rule. Some items are identical to others. Okay, remember the example we cover for the number 3 and number 4, right? In these two examples, we say we want to know how many ways can the letter be arranged. And these two examples, we don't have any repeated letters, okay? No repeated letters. So we could just count how many letters do we have in here and use the factorial. Okay, and this is the permutation rule, and this is for you guys to take care of the questions just like the example 7. How many ways can you rearrange the letters of success? So in this example, you could see I do have a repeated letters. So we have to apply the permutation rule. Okay, first, you're gonna count how many letters do we have in here. We have 1, 2, 3, 4, 5, 6, 7. So we have 7 letters here. Now look at it. Which letter is gonna be repeated? We have S and C. Okay, so count for it. How many S do you have and how many C do you have? We will have 3 S and 2 C. So in this example, we're gonna do 7 factorial because we have 7 letters. And then divided by, we have 3 repeated letter of S and 2 repeated letter of C. So we're gonna divide it by 3 factorial times 2 factorial. I will just put the parentheses on the bottom here. Okay, when you guys use the calculator, you're gonna do 7 math probability factorial divided by parentheses 3 factorial 2 factorial. Close it. Okay, make sure you do have parentheses in here and then enter. So that will be 420. Okay, make sure don't do that. Don't just divide 3 factorial 2 factorial. Don't do that, okay? This is two different things. This is means 7 factorial divided by 3 factorial and then times 2 factorials here. You could see you're gonna get a different answer. Okay, so keep in mind when you're working on this kind of the question, put the parentheses on the bottom. try to do the example 8. So how many letters do we have? We do have 11 letters. And which letter is going to be repeated? We have I, S, and also the P, right? So we have 4S, 4I, and 2P. So you will have 11 factorial divided by 4 factorial, 4 factorial, and 2 factorial. You should get this answer. Okay, next one. Combination. We just learned the permutation. The permutation rule, the NPR, talking about the order doesn't matter. Okay, then this one, the combination rule. Same idea, just like the combination rule, we'll be using when the order does not matter. Okay, same thing, you will have the N, how many items you are available, and how many items you want to pick, that will be the all. Okay. The formula is really similar, only for the NCR, we're going to divide it by the R factorial also. Feel free to use your calculator for the homework and the exam. So look at the same example. We have a 3 letters and we want to pick 2 of them, and order doesn't matter. So first, what is your N and what's your R? That will be N equal to 3 and R equal to 2. Okay, order doesn't matter, means AB will be equal to the BA. So we just count, this is like the same way to arrange it, okay? AB equal to the BA. So we're gonna use the combination. You could plug in the formula or you could just use your calculator. That will be equal to 3. So we do have these 3 choices, AB, AC, or BC. Okay, let me show you guys how to use the calculator. So we have a 3, math, probability. This time we're gonna pick for the number 3 here, NCR, and then R equal to 2. Enter. So that'll be equal to 3. Okay, try the example 9. "30 people attend a certain event and 5 will be chosen at random to receive prize. The prizes are all the same, so the order in which the people are chosen does not matter. How many different groups of 5 people can be chosen?" So again, first we need to figure out what is your N and what is your R. So N means how many items are available. So we have 30 people in here. So 30. And R means how many you want to pick. So we want to pick 5 of them. So R equal to 5. And then read the question carefully. They say the people are chosen does not matter. Okay, means you are the first one or you are the last one to pick, you're gonna receive the same prize. So order does not matter. So that's why we're gonna use combination. So that would be 30C5. Okay, use the calculator. You should get this answer. And then try number 10. For this one, we are looking for the probability, okay? Find the probability of winning a lottery with the following rule. Select 6 numbers from 1 to 40 in any order, no repeats. So again, when we talk about the permutation combination, this is only talking about the total outcome. Right now, we are looking for probability. So first, figure out what is the total outcome. So what is your and here? What is your or here? Are you going to use permutation or combination? We're gonna use the combination, right? Because this is in any order, no repeat. So that will be the combination. And then we have a 14 numbers are available. We only pick 6 of them. So that will be 40C6. And again, this is talking about the total outcome. What is the probability to win the lottery? We only have a one set of the number to win the lottery, right? Only have a one set of the number. So probability will be equal to 1 over the total outcome. Okay, that's it for the session 4.4.